In this question, we're going to analyze a World Hockey Championship division. Our teams are playing each other. And in this division, we've got Canada, Finland, Germany, Slovakia, and United States. And there's a nice little table where one team is playing another team. And this table is defined with the operation verse. And that's what we're supposed to analyze. So the first question we're supposed to look at is if our set is closed under the operation verse. Now we notice some kind of funny things going on in the table, like when Canadians play Canadians, I guess you get more Canadians. When a different country plays a different country, it kind of makes sense. But nonetheless, you can still define the operation on the set and get things. Here we have to make sure that these things that we're getting out of the operation are all included in the original set. And if we look closely, we find Russia is just not in the original set. So Russia is not an element of our set, so it's not closed. If we couldn't find an example outside of the set, then it would be closed. Is the operation commutative over the set? So what we can check here is to make sure the top triangle, if we go down the main diagonal, is symmetric with the bottom triangle. So as we look through the rows and columns, everything is symmetric except for United States and Slovakia. So when United States plays Slovakia in Slovakia, as compared to when Slovakians play the United States in America, the home team always wins. And that's different if we look at the order here. So Slovakia wins in Slovakia, United States wins in United States, but these are just not the same thing. So we can't flip the order of a reverse operation and always hope to get the same thing. So no, it's not commutative. Associativity is a little bit more tricky. So with associativity, you're always checking this equation. So let's just write down in general. It's A, B, C compared with A, B, C, where the brackets are either on the first part or the second part. And you're always interested in whether that equation is equal or not when you're checking associativity. Now, if we look at the table above, we notice that Canada just dominates at hockey. They crush every other country. They always win. So if any one of these letters is Canada, Canada will win. We don't really need to worry about that case. If Canada isn't playing, the same is true for Finland. Finland is the second most dominant country at hockey. And then we move on to Germany, who's just terrible at hockey. They keep losing to every other team. So the only way to make this false is to look at United States and Slovakia. There might be a way to make it false with those teams, but there certainly isn't a case to make it false with any of the other teams, because they're either always winning or always losing. So let's just try an example with United States and Slovakia. So United States, let's say, plays Slovakia, and then after that result, they play United States again. So if this happens, remember the home team always wins, so it's Slovakia versus the United States, and then the home team wins again, United States wins. If we do this the other way around, so we got USU, and then SU plays, so Slovakia, United States wins out in the brackets. But this time around, if we look at our table, we get Russia. So these two things are just not the same, so it's not always true that you can move the brackets, so we're not associative. All right, the next question, does the set S have an identity element with respect to the operation verse? And if it does, what is it? So the rule that we can check when we have a table is to look at the very first row and the very first column and see if there's a copy of that somewhere in the table. And if you look through, Germany is that example. Or the identity is the one that's always losing with the verse operation. So in algebra, if you check Germany and you compare it to anything at all, let's just say it's X, that Germany goes away, they just lose the game, X wins, and the same goes for the other way around. Doesn't matter if Germany is a home team or away team. So yes, the identity is Germany. And then finally, do any of the elements in the set have inverses with respect to the operation? So we can go through up to our table and look for the identity as a result, because the inverses will take us back to the identity. So Germany appears when Germany plays Germany, and also when Slovakians play each other, you get Germans. So do any of the elements in S have inverses? Yes. Germany and Slovakia both have inverses. And if yes, we're supposed to give an example of a team other than the identity. So we're not supposed to give G as the answer. So yes, Slovakia has an inverse. And that inverse pairing is actually, it's just paired with itself. Slovakia versus Slovakia gives you Germany.